Welcome back everyone. Today we will discuss the topic inductors and we will discuss it by a very famous experiment, right? So this experiment showed that when we change the current in the first coil, which is connected to of course a voltage source somewhere, right? And when we make this current variable, that is sometimes we increase it, sometimes we decrease it, there is a change in this coil which is not connected to any source. This is a galvanometer which measures the direction of current and the amount of current, right? So the galvanometer shows some deflection although it is not connected to any voltage source or current source, right? So why is this? This is because of inductance. And we see that the voltage, there is some potential difference generated in this coil, right? And there is a change in current with respect to time, right? With respect to time. So I can say that the voltage developed in this coil is proportional to the current, change of current with respect to time in the first coil, right? And when this is proportional, we remove the proportionality sign with a by replacing this with a proportionality constant, and we can say that V is equals to L di by dt, and here L is the inductance, right? And is measured in Henry. Since you saw because of this there was an inductance and a voltage developed, we can use inductors to store energy in form of magnetic fields. Let's take the flux produced from 1 ton is equals to phi, right? Flux from 1 ton, right? So let's assume that there is on 1 ton only and the flux is phi, right? So psi, which is the flux due to n turns, let's take capital N, which will be equal to n phi, right? Let me write it clearly. Okay, and let's take it as equation 1. Now we know that V is equals to d phi by dt, right? Change in flux develops a voltage, right? Here we saw a change in flux developed a voltage with respect to time. Okay, so wait a minute. Okay, I have changed my marker. It was getting sync is finished. Okay, so now we can also say by replacing this value with this, we can say is equal to d by dt n phi, right? And when we open the brackets of the differentiation, you can get n d phi by dt plus phi dn by dt by the product rule, right? Now this n is constant, right? Number of terms cannot be changed, it is constant, so this term tends to 0, and so v is equals to n d phi by dt. Okay, now since phi is proportional to I, right? Because when we are changing the current, we are basically changing the flux, right? And we know that psi is proportional to phi, right? So this means that psi is also proportional to I. Okay, and since we know we remove this proportionality sign, I will take a small I into Li, right? So which also says that V is equals to d by dt Li, right? From here we can say it. And so when we open the bracket, we will get V L di by dt. V is equals to L di by dt, okay, plus I dl by dt. Now this value is constant. We are taking it constant in network theory in ideally conditions, right? But in practical it is not constant. But in here we will assume it as a constant, and so this will be equal to 0. So V is equals to L di by dt. Right? We got this formula.